We shall get started in just a minute. I'm going to get some water because my throat is dry. Okay, there's some stragglers, but I do want to get started just because I know that there's a lot of review I want to do today. So just a quick idea of the agenda. We're just going to finish up reviewing Taylor polynomials because I feel like that's going to be a big topic on BC. And then we're going to review everything in calculus, and I'll have you have this little cheat sheet for you. Okay. Here we go, Taylor polynomials. So we talked last time about how we're going to do them. I just want to work out a few more examples that you'll likely see on the test. For example, you could get a tabular method Taylor polynomial question where they give you this, right? They give you a table in terms of f, but then they give you some other function in terms of h, and then they always give you something like this, right? It's twice differentiable. And then they want the second degree Taylor polynomial for h, right? So you always have to do a little bit of extra work. It's not just using the Taylor formula, right? Because y'all should have that written down, and it's not too hard to do that. Here we have to apply the fundamental theorem of calculus, right? We know what h of x is, and we can do h prime of x. This 4 becomes a 0 when we take the derivative. And then when we take the derivative of this secondary thing, right here, we're going to get f of 2x times by 2. Right, so that's your chain rule using fundamental theorem of calculus. And then from there, we can do the second derivative of h as well. And then we have to do the derivative one more time, so we have to do the chain rule one more time. So it's going to be 4 times f prime of 2x. We've done 2 derivatives. That means we have enough to start setting up our Taylor polynomial. So then I guess the proper notation would be like t of 3 of x, right, will equal h of x. Oh, they give us around 1 though. So let's, instead of doing x, we should do h of 1. And then it'll be h prime of 1, x minus 1. And then plus h double prime of 1 all over 2 factorial x minus 1 squared. Yeah, and then we can start plugging in the numbers that we have here. So h prime of 1 is equal to 2 times f. We plug in 1, so it's f of 2, right? 2f of 2. F of 2 is equal to 0. So this number is equal to 0. And then h double prime of 1 is equal to f prime of 2. F prime of 2 is equal to negative 1. 4 times negative 1 is equal to negative 4. And then all you need to do is plug in numbers, and that should get you, oh, I forgot the h of 1. Let's plug in h of 1 too, right? H of 1, we plug it into here. 4 plus the area from 2 to 2 of f of 2 dt, f of t dt. This translates to 0. So then you get your Taylor polynomial here. Is this term cancels out, so it's just 4 minus 4 x minus 1 squared. So this would be one example, right? Tabular method. And then you have an extra thing to do with calculus. Somebody asks, why did I use f of 2x instead of f of x? Good question. This one's going to apply to both levels of calculus, right? AB and BC. You need to remember the fundamental theorem of calculus. So let me write this out a little bit more explicitly so you can see exactly what I'm doing. When I take the derivative of both sides, right, I'm taking the derivative with respect to x. And then fundamental theorem of calculus says that if I take the derivative and I have a function in the upper bound, taking the derivative would just be as if I were to plug that upper function into the bound and then times it by the derivative for chain rule. Does that answer your question? So that's something that I do want you to look out for. I've looked through a lot of the practice sets that they've been releasing, different questions, and they do have the fundamental theorem of calculus, either where you have 2x up there, or maybe I've even seen like g of x in there, right? So maybe let's pretend there's g of x in there, and if we were to take the derivative, right, then the derivative would be f of g of x times g prime of x. So that's fair game for both levels of calculus, knowing what to do when you take the derivative of an integral with a function in it. Okay, we also have graphical method, right? Third degree Taylor polynomial for k of x around c is equal to 1. So we can just start off, always just start off by writing this so you get that out of the way, right? And then we know it's centered around -1. X plus 1, k double prime of -1, x plus 1 squared over 2, k triple prime -1, x plus 1 cubed all over 3 factorial. And then from there we can read the question then, right? It says the function has k derivatives for a portion of the graph k that is shown with the line tangent to the graph. Then it says for n is greater than 2, we're going to use this function over here. And so then all you need to do is pick some points from the graph, right? So if this is the k graph, we just know that k of -1 is -2, right? And then if we have the tangent line, we can just calculate the slope of the tangent line, right? It's up 1 over 2, so we can say k prime of -1 is just 1/2. And then from there, if we're using this derivative notation, we're just going to plug in various values for n. So k double prime means we're going to plug in 2 here, right? So we can just literally plug in 2 factorial over 3 over 2, x plus 1 squared. And then same thing, right? For the third derivative, 3 factorial over 4, all of which over 3 factorial, x plus 1 cubed. And then you can choose to simplify if you'd want to or not. Cool. So either a table or with a graph. This one's with a piecewise function. It's the same idea here though, right? You just need to know if you get an odd number, you plug in the top. If you plug in an even number, it's just not going to exist. Okay, this is another type of question that I've seen that's very, very common on either free response or multiple choice. Find the value of f triple prime of 2. So maybe on the test you will have worked out a polynomial and not know what f triple prime is, right? So then if we want triple prime, then we want this one, right? So then this, whoops, I missed the negative sign. This is our coefficient, -4/9. Right, so when you're setting up coefficients, you're going to go, here's my coefficient for my function, and then that's equal to f triple prime of 2, right? Because it's centered around 2. Even if they didn't tell you what it was centered around, you could tell by what's being minus inside the parentheses, right? It's equal to f triple prime of 2 over 3 factorial. And then it's really quick to solve for f triple prime of 2, right? You just go ahead, multiply that 3 over, so it's -4 times 3 factorial over 9. And so we have this final question here that I want to work out with you. It's a little bit more conceptual, but I think it's also fair game. They want the coefficient of the 26th term. So what does that mean? If we want the coefficient of the 26th term, that means we want g, the 26th derivative of x over 26 factorial, right? That's what we're looking for. Just a reminder that when they say Maclaurin series means it's centered around x equals 0. They're probably just going to say x equals 0 on the test. But just know that that's the case. So instead of g26 of x, I can say g26 of 0. So we're going to have to do a little bit of investigation here, right? So we know g of x is just equal to e to the negative 2/3 x. And then what we get g prime chain rule, right? So negative 2/3 e to the negative 2x, 2/3 x. G double prime, negative 2/3 squared e to the negative 2/3 x. And at this point, you can probably see what the pattern is, right? And so you want to make sure that you look at it carefully. So whatever the number of the derivative is actually going to equal whatever the power is. But sometimes it's going to be off by 1, though, or off by 2. So make sure you just don't assume. So in this case, the 26th derivative, and if you write it out on the test, make sure it's in parentheses, is going to be negative 2/3 to the 26th e to the negative 2/3 x. From there, we can plug in 0 into the function. Anything to the 0 power is 1. So then the value of the coefficient is just going to be negative 2/3 to the 26th, all of which over 26 factorial. Yeah? So that's a little bit more conceptual. I can imagine them giving it to you with e to the kx maybe, with letters instead of numbers. Cool. So what's the most common pitfall when it comes to the Taylor polynomial? People forget this thingy here, right? That's thing number 1. Thing number 2 is they forget to plug in the center value. They just have like an x there or something. So that's a review of all the Taylor type questions that I think you could see on the test. Does anybody have any questions on there? If not, I'm going to start doing a review of everything we've learned so far. Okie doke. And this is where I hope that y'all can participate. See if you can jog your memory, right? So I'm just going to bring up this document of different things that you might see on the test. And I want you to be able to answer for yourself too, right? I don't want to be the one providing answers to you because hopefully I'm not telling you what the answers are on test day. So if you see the phrase find the zeros, what should you think of on the tests? Solve for x, right? Obviously solve for x. What are some ways? Yes, factoring, exactly. Factoring might be a way. Another way you might want to think about it is you might need to use quad form. Quadratic formula. Basically f of x equals 0, right? Okay, what about part 2? Find the equation of a tangent line to f of x on a to b. Slope, how do you find the slope? Usually. Take derivative using this notation though. How would we use this notation? Which point? Which point on here? No, not tangent line. You gave me the equation of a secant line. Tangent line. So tangent line, the slope is going to equal f prime of a, right? Not f of b minus f of a. That's average rate of change, right? And then we can plug in the point, right? So if we want to do the point slope formula, it's y minus b is equal to f prime of a x minus a. I'm using the exact points they gave here. Normal line, we haven't really talked about that, but I hope you all know what that means. What do you think normal line means to do? One person doesn't know. Perpendicular, exactly, perpendicular slope. So in this case, m is going to equal 1 over f prime of a. That's what normal means. I don't know why they have so many words for perpendicular. Normal, orthogonal, I don't know. I don't know why they don't just say perpendicular. It's just another word. Maybe it's used more in like 3D because you can have a bunch of things that are normal to each other. Show that f of x is even. I'll just give this one to you. That means you have the same y value irregardless of the sign. Irregardless, that's not a word. Regardless of the sign. And then f of x is odd, right? So that, right? Or you can think of something that has y-axis symmetry, right? Or you can think here. Thank you for telling me negative. Yes, negative 1 over f prime of a. Thank you. Perpendicular. Number 6, find the interval where f of x is increasing. What's your job there? Find the derivative, do a number line test, see where it's positive, yes. Find where f prime of x is greater than 0 is basically what it's saying, right? Somebody said if velocity and acceleration have the same sign, that's speeding up. Okay, so that's a question for later. This has not necessarily, it doesn't necessarily have to do with speed here. So we're finding where f prime of x is positive. What about the next one? Find the interval where the slope is increasing. Yes, and then for both of these, you can use a number line test, right? Remember the number line test is not justification, but it's there for your understanding, right? So we want to find where f double prime of x is greater than 0. Find the minimum value of a function. What are you supposed to do there? Number line test, negative, then positive. Kind of. Number line test is part of it. Pay attention to the wording though. Remember, number line test is not proper justification. Find where f prime of x goes to, yep, find where f prime of x goes from negative to positive. What else? Yes, we need to find where f prime of x is equal to 0. Not just 0 though. F prime of x is equal to 0 or undefined, good. The last thing is you have to, they say the minimum value. They're not saying relative min, right? So when they say minimum value, you need to plug in all minimum candidates. We might have to check endpoints. Yes, 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 yes. So we need to plug in all your candidates. There's another one specifically with endpoints, okay? Can endpoints be mins or maxes? Yes, endpoints can be mins or, let me clarify, endpoints can be absolute mins or absolute maxes. Endpoints cannot be relative mins or relative maxes. So I bet there's somewhere for me to write that too. Endpoints can be absolute mins and absolute maxes. Find the minimum slope of a function, same idea, right? Everything here except set f of x equal to 0 or undefined, right? And then you need to plug in all the minimum candidates. Ooh, and to clarify, in this one, right, for the minimum value, you're going to plug into f of x, right? And then for this one, you're going to plug into f prime of x because f prime of x represents the slope, right? Okay, we said critical values, right? So f prime of x is equal to 0 or undefined. Find inflection points. What do we do for inflection points? Okay. F double prime of x is equal to 0 undefined? Yes. And then yes, Alita said it. Not only do we need to do 0 to undefined, we need to check that signs change. You can do get a critical value of 0 undefined and the signs may not change. Yeah. Okay, number 12. How do we show that the limit exists? No, plugging it in does not show that a limit exists. Not three limits. Limit from the left is equal to the limit from the right, yeah? So how would you write that out? The limit from a approaches x minus, right? There's only two things to check to show that a limit exists. Not the value. You do not need the value to show that a limit exists, right? You can have a limit exist and still have a hole where the value is, okay? Now that's different from number 13. Number 13 is where you need the value to exist. So number 13 is where you have all three of them. Limit from a left is equal to f of a is equal to limit as you approach from the right-hand side of f of x. Okay, so make sure you pay attention to the difference there. Print out this cheat sheet if you want when we're done with this, but 2 things for limit, 3 things for continuity. Find vertical asymptote. That one should be pretty simple, right? You've done that forever. Oh, there is a trick here. I wrote down the note, there is a trick. Anybody know the trick for this one? Yeah, that's true. F prime would be undefined if there's a vertical asymptote. Look for the value that would be 0 in the denominator. Yeah, that's true. There's the trick though. So the trick is you have to remember factor first. Then set your denominator equal to 0. All right, if you don't factor first, then you might get a hole. So make sure you factor first before you assume there's a vertical asymptote. What about horizontal asymptote? What is the calculus definition? That is not the calculus code. You can do that, but that's not the calculus definition. Calculus definition is the limit as x approaches positive infinity of f of x and the limit as x approaches negative infinity of f of x, right? That's the calculus definition of horizontal asymptote. So if they ask you something like that on the test, you have to write, why does that say n? That should say x. So you have to say something like that, okay? What else do we have? We have find the AROC. Y'all know how to do AROC, right? I don't even need to go over that one. Y'all should know IROC too. I'm not going to go over that one either. How about 18 though? Find the average value. Average value of f of x. Yeah. Yes. 1 over b minus a of f of a to b of f of x. What do people forget? They forget and they do the derivative, okay? Not f prime of x. Okay, so if you want the average value, so for example, if you want average velocity, you plug in velocity. If you want average acceleration, you plug in acceleration. So notice that this one was different from earlier. This one, they gave you endpoints, right? So critical values, let me say plug in critical values and endpoints. Okay, number 20, how do you show that a piecewise function is differentiable at a point A? How do you show that a piecewise function is differentiable at a point A? Set the values equal would be for continuity. Yeah, y'all are skirting around it. So the definition of differentiable means that limit as x approaches a minus of f prime of x is equal to f prime of a, right, is equal to f, oops. So you need to show that the limit of both sides, right? So you need to find the derivative and set them equal to each other at a. Right, take the derivatives, set them equal to each other at a. And then this is the true calculus notation if you want the true calculus notation. What's next? We have this one, S of t, find v of t. How do we do that? V of t is equal to S prime of t, good. Okay, pay attention to the wording for the next one. How far a particle travels given v of t? How far a particle travels on A to B? Aha, I got disagreement. This one is, it says how far it travels as total distance. This would be A to B of absolute value. This is not displacement. This is total distance. Average velocity, what do we do there? We can do that way. That is one way. We can do 1 over b minus a integral from a to b of v of t. That is absolutely one way. Can anybody think of another way? Or the AROC of the position function, right? So here you're using s. So I'll just use s of b over minus s of a over b minus a. Right? I think this one is a fascinating equality here. And it sometimes gets overlooked. Okay, given v of t, determine if the particle is speeding up. So somebody already answered this there, right? So v of t and a of t must have same signs. What about 25? I don't know what the position formula is, but y'all are correct, right? So if there's a couple ways. So you could do integral of v of t dt is equal to s of t plus c, right? That's one way of doing it, and then plug in for c, plug in to find c. That's way number one. Way number two, which I think is often more easy for me, is just v of t is usually just right, whatever that is, if we're starting at 0. That way we can know to add it over, right? Two ways. You can set it equal to c, or you can the fundamental theorem of calculus. Either way works. Just, I think the thing is, you cannot forget that s sub 0. That's going to be huge. I wouldn't be surprised if that were one of the things that showed up on the test. Everybody's favorite. How do we show that Rolle's theorem holds? How do we show that mean value theorem holds? Small. Rolle's is not IVT. IVT is IVT. But f of x must be differentiable on open a comma b, right? Because we don't do the closed interval for differentiable. And then f of x must be continuous on the closed interval a comma b, right? So that's the setup for both of these. And then what's the difference between these two? Let me copy and paste. So I have this, copy and paste. So then for mean value theorem, we can say that, I can say I'll write a rock equals I rock, right? That's my notation. But you can just say f of b minus f of a over b minus a is equal to f prime of c. That's for mean value theorem. And then for the top one is just f of b minus f of a is equal to 0, right? This one is equal to 0 for Rolle's theorem. And remember the trick that we saw in the last test, right? It doesn't just have to be the endpoints. Any subinterval could also hold, right? So make sure to check subintervals if you get an MVT or a Rolle's theorem. I'm going to put this over here. Check subintervals. Cool. Find domain. I think, I mean, the only reason why it's here is that assume, the test does assume f of x exists for all real numbers, right? When do you not? When you square root, right? When else? 1 over x, right? When else? ln of x, right? Those are the few times you have to be careful when you have a denominator, when you have a square root, when you have a log. I don't think you need 29 and 30, honestly. So I'm just going to skip those. All right, 31. By definition, how do you find f prime of x? By definition. That's the power rule. That's not the definition of f prime of x, though. There's two. Yeah, using limits. Yes, limit definition, like the H thing, perfect. So the one of them, like the H thing, is what? F of x plus H minus f of x exactly all over H, right? That's one limit definition. As H gets infinitely small, right? You get closer and closer. The 2 points are closer and closer together. Or you could have 2 points, right? So as x approaches that other point, maybe you have x of x minus f of a. This is your slope formula, right? And then as the 2 points on your slope get closer and closer together. Okay, this one's everybody's least favorite. What do you do here? What the heck? How likely? I don't know. I feel like all these things kind of stack on each other. That's why I'm going over all of it. There's a few that are relevant though. People miss the average value one. Absolutely finding max. That for sure show up. I don't know. Do we need to do the inverse one? F inverse of f of a. 1 over prime. Something like that. I don't know. I'm not going to worry about 32 that much. I will just put a big X through it. 33 likely to show up. What does 33 mean? X is increasing proportionally to, or sorry, Y is increasing proportionally to Y. This one is dy dt, right? The rate of change of Y is proportional to Y itself. Right? Remember when you have this, this can be rearranged into Y is equal to C times E to the KT power. Yeah, so this is one of the examples of differential equations. So they could give it to you in words. 34. Using integrals, how would you find the line C that divides the area under f of x on a to b into 2 equal areas? This one's an interesting question. Anybody know how they put this one up? I'm glad we went over this because this wasn't one of the questions that we went to. So if you have this x of c, right? So what you want to do is you're going to set one integral from a to c of f of x dx, and then you're going to set that equal, and then starting from c to b of f of x dx. Right, so I've seen this on the test where it says write but do not show an expression that equates, that you could solve to find that magic line x equals c. Okay, 35, what's the answer? No dx. Remember, this dx and the integral cancel each other out, right? So it's just f of x. It's just f of x. This is the fundamental theorem of calculus. When you take the derivative of an integral, you just get the function itself. Okay, part 2. I don't know if you can see that, but it says from a, so a is a constant, and then u is on top, okay? So a on bottom, and then u on top is a function. How would you answer 36? Not f of a. Not f of u either. This one is f of u. This one you have the derivative of u. So you could say u prime, or some people say f of u du, right? This is the expression that we did earlier when we had that integral, right? We had the integral from 0 to 2x of f of x dx. Oh, no, it shouldn't be the same letter, right? Remember, if we have the x in the integrand, we have to do a different letter, right? And now if we take the derivative of that, right, we get f of 2x times 2. That's the du part on the outside. I'm even going to break out my highlighter and start highlighting this one because I think this is high likelihood there. This is an easy point to get, easy point to miss. Okay, somebody asked me to clarify the difference between 35 and 36. So notice in 35 that your function is x, right? It's kind of like chain rule. Before you learned chain rule, you didn't realize that you're doing chain rule every time you took a derivative. This is actually doing the same thing. If I times it by my du, I'd be timesing it by 1. So the whole idea with the fundamental theorem of calculus is whatever that function is, you can go ahead and take that function, plug it in, but then if you're taking the derivative, you're going to have to do chain rule. Right, this thing on the outside is saying take the derivative, and whenever you take the derivative, you should be thinking about chain rule. And I'll make a note of that. I think there was test questions. Anyways, I'll make a note of this, and then we'll take a set review after we bust through the rest of these things, because I do think this is important. The rate of change of a population, you just need to know, you can just write dp dt, that's not a big deal. Okay. What if you were to see this statement, the line y equals mx+b is tangent to f of x at a comma b? What can you infer from that statement? So here we can infer that f prime of a, right, the slope of the tangent line is equal to m. I think y'all are good with the next four, right? Riemann sum, midpoint, trapezoid. Does anybody need me to review any of those? Okay. 43. Can I write trapezoid? Absolutely. How do I write midpoint? I don't know how to write midpoint, honestly. You need to, how about this? I'll work through a midpoint example later if we have time. Trapezoid for sure. So remember that the area of a trapezoid is 1/2 base 1 plus base 2, right? We're averaging the bases and then we're timesing it by the height. So what is the base of these trapezoids? The base of these trapezoids is, you can say 1/2, you can do f of 0 plus f of 1, right? So the function values will be that. And then what will be your height? Your height will be your change in x. The two bases are the y's and the height is the x, yes. Right, so this is base 1, this is your base 2, these are your y's, right? And then you keep going down the line, plus 1/2, now you do f of 1 plus f of 2, right? And then you do the changes in those bases, right? So every time you just add another trapezoid. I think this is pretty easy if you draw out the picture. But it sounds like we have Riemann sums, so I'll make sure I save some time for the end to do a couple of Riemann sums as well. What is this? What do you need to remember for solving differential equations? This one's huge if you get one on the test. Like out of a 5-point question, if you don't do this, you might get 2 points max out of 5. Yes, isolate y and dy, isolate x and dx. Yes, isolate y with dy and x with dx. That's true. What do you need to remember though? Don't forget, yes, don't forget the plus c. They will deduct like crazy for this one. I don't know why on this particular question, but don't forget the plus c when you integrate. Okay, what is the meaning of the integral from a to x of f of t dt? What is the meaning? No plus a. No plus a on this one. This one's the total area. Oh, I mean, you said total area. That's maybe. Area under the curve between x and a. Yeah, that's true. A and x. What else? There's another way of thinking about integrals. One is geometrically, which is the area under the curve. We can think of this as the amount accumulated between a and x. Not total amount. Is the amount accumulated between a and x. Cross sections perpendicular to the base are squares. Right, so this would be the integral from a to b of the base squared dx, right? And then the base is probably the difference between functions, right? Base is probably like f of x minus g of x. Question mark, maybe. What does it mean when it says find the tangent line to f of x is horizontal? Set dy dx is equal to 0, right? Find the tangent line where it's vertical. If dy dx is a fraction, set denominator equal to 0. Find the minimum acceleration given v of t. Find the minimum acceleration given v of t. What are your steps there? Nope. Nice try, you're so close. You gotta pay close attention to the wording here. Yes, we want to find v double prime of t. We want to minimize acceleration, right? So you can think about it as do a prime of t is equal to 0, right? Or you can think of v double prime of t. That little apostrophe might haunt some of you on the test. Just be careful with the wording. You all know how to do tangent line approximations. I'm not going to worry about that. 50, given the value of f of a and the fact that the antiderivative of little f is big F, how would you find big F of b? So this one, we're going to take the integral from a to b of little f of x, right? And then if we take the integral, then we should know that that's equal to big F of b minus big F of a. Yeah, that's how you do that. Something along those lines. 51 is the chain rule, right? Chain rule, f prime of g of x times g prime of x. I have a feeling this might show up on the test too, because it's harder to do it when it's abstract like. $52, if you're given that, how would you express this and take the antiderivative, assuming that we're going to use capital F for the antiderivative? What would the answer to this be without using an integral expression and actually taking the integral? We can split into two different integrals. Well, we don't necessarily know the value of the first. I just want to take the integral knowing that, yeah, good. Okay, so that's right, yeah. So if we split it up, right, if we split up the first one would be f of b minus f of a. We did that earlier, right? Big F of b minus big F of a. And then when we take the integral of a constant, right, it'd be k times b minus a. Right, this would be your answer for this one. And then if y'all need to know, we can split it up, right, into f of x dx plus integral of k, right? Integral of k is a constant. Cool, given a picture of f prime of x, find where f of x is increasing. What would you do there? Find where f of x is increasing. Look for what? Look for where, yes. Where, when, well, it could be when, where f prime of x is positive. Positive is also above the x-axis, right? Good. What's this one? Given v of t and s is t, find the greatest distance from the origin of the particle. What the heck does that mean? Find the greatest distance from the origin. Area under the curve is the largest, that's true. Where you have the greatest area under the curve, that's possible. Where x of t and v of t are opposite signs, that's not true. That's moving towards the origin. Okay. So somebody said where x of t and v of t are opposite signs. So let's say x of t is positive, right? That means maybe you're at the right of the origin. And then v of t is negative, that means you're moving left. So that means you're moving towards the origin. You actually kind of want to find where you're moving away, don't you? Technically. So you kind of want them to have the same signs, but actually not. What you're supposed to do is here set v of t is equal to 0. Right? It's literally like finding a local max or finding an absolute max. So this is finding an absolute max. By plugging critical values into S. So this is just the application of absolute maximums when you're talking about particular motion. Okay, this one's another one. So we have a fill rate. We have an empty rate. How do you find the water, the amount of water in the tank at m minutes? Pay attention to the wording here. The amount of water in the tank at m minutes. Amount of water. T1 to T2 of f of t, integral from t. Yeah, okay, yeah. So y'all are close. So we're gonna take the integral from T1, right? That's our starting point, to M, right? We're gonna do the fill, right? Fill is positive, empty is negative, right? The integral from T1 to M of f of t minus e of t dt. But this one says amount of water. When they say amount, they're implying total amount. So then we need to plus G, right? Total amount versus amount added. Please, please, please pay attention to the difference there. The rate at which the water is changing. What do you do there? The rate, it says G gallons initially. G is initial. Find the rate at which the water amount is changing. The rate at which the water amount is changing. At M. F of M minus E of M, right? This is the rate, right? These are the two rate functions, right? This is the accumulation function. This is the rate function, right? It's kind of like amount is the original and then rate is the derivative. Technically, you could take the derivative of that. If you took the derivative of that, right, you'd get that. Okay. This is something that I think all y'all do need to review a little bit before you take it, because I feel like they love these questions. The time at which the water is at a minimum, what do we do there? Yeah, optimizing. How would you optimize it? It's not a common. Yeah, amount of water. Yes. Yes, amount. When they don't say water, I mean amount of water. So for this one here we do E, yep, E of, or F of T, F is fill. Fill minus empty, right? And we set it equal to 0, right? This is how we optimize it, because the fill and the empty are your derivatives here. And I think kind of weird because we're so used to seeing the apostrophe with the derivative. For 58, right? If they give you a table and then you want to find F prime of C, pick the two closest points to C, right? If you don't pick the two closest points, you won't get the point. You won't need to draw a subfield. No. Find the area between two curves, right? A to B. Depends which one's on top, right? G minus F, assuming G is on top. Find the volume if it's rotated around the x-axis. Pi A to B. G squared of x, yep, disk and washer, minus F of x squared, yep. Cool. Aha, this one. Everybody loves this one. This is a setup you need to show too. You need to show this when if you're gonna do this. So please remember to do that. I think this is worth 1 point. If you don't, that's an easy point for you to gain. L'Hôpital, with or without the S, however you want to do it. Okay. What are you supposed to do for indefinite integrals? Yes, limit as b or some other letter approaches infinity of 0 to b of f of x dx, right? And then your next step is to write out the limit as b approaches infinity of big F of b, right? Minus big F of 0, right? If you do not do this limit notation, you will be docked. Logistics equations. If you get into just either logistics equation on the left or the right, what can you tell me? In this case, the P is your Y value. M is the carrying capacity. Good. M is carrying capacity. And then M over 2 is fastest growth. Good. What do we do for 65? Partial fraction crap. I don't think you're going to get it, right? It's so easy to plug in a partial fraction into the calculator. None of this, none of this, none of this, none of this. Y'all need to know how to do B. 70B. When does the particle stop? Yeah, V of t is equal to 0. That one's easy. Don't need this. Don't need this. Don't need this. Does anybody need me to redo Euler's method? Iki. It's going to be hard to do it on here. I'll do it on a separate problem. I don't think you need to know if Euler's estimate is a over or underestimate. I don't think that's necessary. What do you do for 76? Integration by parts, right? Ooh, I don't think they'll have you do this one, but well, we'll just do integral of u dv is equal to uv minus v du. I think they'll have you do it with the general functions. I don't think you need to know 77. I don't think you need to know 78. I mean, you can do Maclaurin series, right? It's just what f of 0 plus f prime of 0 plus f double prime of 0 right over 2. x squared x. It's not a big deal. Yeah, I think honestly, if you want to do that, yeah, I don't care too much about the cosine one. 79 is easy, right? That integral converges if p is greater than 1. What about 80? So I don't know if y'all noticed this, but this is a geometric series, yeah? So what can we say here? Our A1 is 2, right? And then what are we multiplying by every time? We're multiplying by 3x every time, right? So then if we want to find the total sum as we approach infinity, we could say 2 over 1 minus 3x, right? And then we can plug in negative 1/2 into that. So this would be an example of a calculus. 1 minus 3 times negative 1/2. Okay, just so you can recognize geometric series. You don't need to find integral of convergence. You don't need that. This one, right? I mean, you do need to know that. I'm just not going to cross it out. You don't need to know Lagrange error. Give you this one just for the heck of it. I don't think you'll need to know it. This one's e to the x. This one's sine of x. This one's cosine of x. Okay. I think there's one more that we need to go over for the BC people. This one, 91. Arc length. They use S or L. L is equal to the integral from A to B of 1 plus the derivative of x squared, right? Not the function, the derivative of x squared, dx. Volume 1 is rotated around the y-axis, right? So y-axis is opposite. It's the integral from bottom to top. Bottom to top. And then you have to write the function in terms of y, right? Yes, dy. Yes. Use y. Nice. We did that review faster than I expected. Okay, so we got a couple questions that y'all want me to go over. One was the thingy bobs. One was midpoint Riemann's. Let me find my midpoint Riemann's. And then another one was Euler's method. Okay. Let me do this one. Let me add a thing here. Okay. Here we have an Euler's method question. Let h of x be the particular solution to this differential equation, blah, 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 with h of 5 is equal to 6. Use Euler's method. Oh, we need to include the graph here. If I don't include the graph, you can't do it. Here's the graph of f prime of x. Okay, so here's how I do Euler's method. I make a 5-way t-chart. Okay, so what I do first is I do my starting point, right? So my x comma y, my starting point is here. And then here I put in my dy dx. So I need to calculate my dy dx given these points, right, at 5, 6. Or no, I'm not going to put that up there. I'll put in x comma y maybe. And then over here, I'm going to put delta x. That's my step size. And over here, I'm going to put delta y. Okay. So they say they want us to approximate h of 3. That means we need to get from 5 to 3 using 2 steps. Well, if we want to do 2 steps, right, it's just going to be 5, 4, 3. Right, so what does that mean? So if I'm going to do 2 equal steps, my delta x is going to decrease by 1. It's going to decrease by 1. So that's the starting process for me to understand how I'm going to use Euler's method. Okay, so I have these 2 points, and then I'm going to plug these 2 points into the slope equation now. So I know my y is equal to 6. I know my x is equal to 5, so f prime of 5 over 5, right? And this is the f prime graph, so I can collect my f prime of 5 as just -2. So my first dy dx is just going to be 6 minus -2 over 5. That's 8 over 5, which is also 1.6. Okay, so 1.6. And so this is my actual derivative. These two, for me, represent my approximate derivative. So I can just say dy dx is equal to 1.6, right? And then I know my dx is -1. So then I know my delta y is -1.6. So basically the idea here is whatever this y is divided by whatever this x is should equal that box over there. And then, well, that's my change in y, right? So originally I started my y at 6. If I'm decreasing by 1.6, then my new y is 4.4. Now I go ahead and I plug in everything again, right? So if I plug it in, I get 4.4 minus f prime of my x value is 4, all of which over my x value, which is 4. My f prime of 4 is 0. So 4.4 over 0 is just 1.1. I can do this setup again, but I see my delta y is, I don't know what that is, but my delta x is -1, so this should just be -1.1, right? And then that means my y is decreasing by 1.1, so I get 3.3. And so then from there, I can just say h of 3 is approximately 3.3. That's how I do Euler's method. Any questions there? Okay, let me find the tabular thing. So here's just a random table, right? So just as a type of exercise, right, we can do area by trapezoids or area by midpoint, right? Trapezoids, I'm going to do 4 trapezoids. Right, so this, the distance between here and here, that's actually my height, right? This is height 1, this is height 2, this is height 3, this is height 4. And just to reiterate, we always have, you're likely going to have different heights. And then these are your two bases, right? So the first trapezoid is 1/2 base 1 plus base 2 times the height. The height is the difference between those two values, right? Plus 1/2 base 1 plus base 2 times the difference in the heights times 4 plus 1/2 base 1 base 2 times the height. That's the difference of 1 plus 1/2 base 1 base 2 times the difference of the heights. So you get that's 2. So those are your 4 trapezoids, right? Now, if I wanted to do midpoint with these, I would need to know the middle points, right? So I cannot do adjacent boxes here. So since I have 5 boxes, the max number of boxes I can use is 3, right? I can only use 0, 5, and 8. So now let's try midpoint. I'll do a different color so you can see the difference when I upload these notes. Now, I have to do the distance from here to here, right? If I want to do midpoint, and I have to do the distance from here to here. Okay, so I can only make 2 rectangles right now. So my first rectangle is going to have a base of 5, right? 5 minus 0. And out of these 3 points, I'm not going to pick the left point. I'm not going to pick the right point. I'm going to pick the midpoint, right? So 15.1, right? And if I want to do the midpoint rectangle here, that distance is 3. And then I have to pick this midpoint there, 18.3. Questions there? And then there's one more that I want to go over because some of y'all were confused by the, what was it? Some of y'all were confused by the fundamental theorem of calculus. Let me see if I can actually find my notes from one of those days where we did fundamental theorem of calculus. Related rates, definite integrals, fundamental theorem of calculus. I think this has to be it. Oh, not there. Maybe I don't have it. Let me just quickly do this review though, for those of you who are struggling with the fundamental theorem of calculus. Okay. So let me give you this example that really helped clarify it for me. So let's say I'm taking the integral from like 100, okay, to x of f prime of t dt. So what is that saying? Well, I want to take the antiderivative of f prime of t, right? Well, what's the antiderivative of f prime of t? My antiderivative is just f of t, isn't it? That's kind of a fact, right? And then what are we going to do? Well, we're going to figure that out from the 2 bounds there, right? So we can just say, if I plug in my bounds, my antiderivative is f of x minus f of 100. Right? That part should make sense. Now, what's the thing here? This is still a bunch of variables. Right? There's a bunch of stuff with x's in it. And what's this? This is some sort of number. Right? Because when you plug in 100, hopefully you get a number. Maybe it doesn't exist, but that's supposed to be a number. Now, let's go ahead and hit this whole thing with a big derivative. I'm going to take this whole thing, hit it with a derivative. That does absolutely nothing to the left-hand side, right? The left-hand side is just dx integral from 100 to x of f prime of t dt. That doesn't change. What happens on the right side? Well, when I take the derivative of this side, this becomes f prime of x, right? And then this f of 100 goes away, that's 0. So using this example, it's as if we were sticking this x directly into there, right? And I think that part makes a lot of sense to people. Let's complicate this a step further. And now let's say I'm plugging in some sort of, let's do 83 to x cubed of f prime of t dt. Right? If we were to do the same exact thing, now I get regular f of x cubed minus regular f of 83. Right? Now, if we were to hit both sides with my derivative with respect to x, what happens here? Well, the left side doesn't change, right? But the right side, we have to use chain rule. So then we have f prime of x cubed, all of which times 3x squared. And then this f of 83, that goes away and becomes nothing. So in this case, you get 3x squared times f prime of x cubed. So then if you want the most general case of the fundamental theorem of calculus, you could have two separate functions in here, right? You could have g of x here, you could have h of x here, and then you have this function f of t dt. If you take the derivative with respect to this integrand, you're going to get f of h of x. We plug in that function, right? But then we have to times it by the chain rule because we're taking the derivative. And then on the bottom, I have another function, right? This time when I plug in a bottom bound, that thing doesn't go away. This is the most general form that I don't think that you'll see. However, I do think it's very likely that you'd see a question like this. You'd have to get this, and you'd have to know that that translates to that. All right, so those were all the misconceptions that y'all had and wanted me to address. Are there any other things since we still have a few minutes? Okay. So the last thing that I want to give y'all is we'll be doing AP exams modeled after the College Board exams. We're gonna follow the exact timing guidelines. You're gonna get 25 minutes to do your work, 5 minutes to upload your questions. You can do one day, you can do both days if you like. And then we will grade your exams and we'll give you commentary on like what you could do to fix whatever mistake you made. Right, so if you haven't talked to me directly, you can either email the office. Yeah, obviously I'd make sure that if you're doing it twice, that you're not taking the same exam. That'd be kind of defeat the purpose, right? You take the same exact twice. Oh my God, got 100%. The idea is, yeah, I'm gonna try to make them different enough so that, you know, that's the hard thing about a 45-minute exam, right? How much stuff can you really cram into it? That's why I want to do it 2 days. Yeah. Any questions? So I'm going to upload the notes from today. I encourage you to look through the notes, rewrite them, right? Put them all on a little cheat sheet for you. Or maybe have a couple pages of the things that you need to remember. If you're forgetting the accumulation, if you're forgetting midpoint, if you're forgetting average rate of change. I don't know why would anybody forget that, but I just couldn't think of anything else. Cool. Alrighty, then that's it. Good luck on your tests. Don't forget your negative signs. Have a good day.